Здравствуйте, друзья, здравствуйте, коллеги.
Distinguished friends, distinguished colleagues, good afternoon. In our presentation, we consider fundamental technologies and the fundamental problems associated with this technology. Outcomes. We expect solutions, or at least ideas, that will lay the foundation for this technology, making this technology more resilient to cyber attacks. The technology is break glass. Yevgeny Frikin and Denis Makrushin. These are our names. We have intersecting competence in high-performance, high-load systems and services. Yevgeny approaches this segment from the standpoint of architecture and resilient systems, and I consider deficiencies and ways to break these systems. The result is our survey. When Yevgeny came up with a hypothesis, what if the break glass technology has some deficiencies, and how can we mitigate this? We took this hypothesis as our basis. What is break glass all about? Break glass in case of necessity. When can this be required in infrastructure? At any point in time, when the infrastructure is under attack, when key resources are not available, when something goes wrong. So this is when an emergency case occurs. This is where an emergency scenario occurs. This is when an admin sees something is wrong. And the only way is to get a backdoor in the good sense of the word. Break glass access refers to a procedure used in critical emergencies or exceptional cases when a user with insufficient access is granted elevated access rights to bypass normal access controls. When do we need such cases? When something is on fire, when something is not available, when something doesn't work. Most frequently, this is when privileged access management or IAM systems simply are not available, do not work. They can be unavailable due to various reasons. Incorrect configuration, updated configuration. Users must be authorized and they're not. Another case is DDoS or MFA do not work. There is a bottleneck, and due to this incident, it is no longer available because it's under DDoS attack. Or rather, there is a vulnerability associated with denial of service. So the system doesn't have sufficient resources, doesn't work, doesn't perform. Or another case, when you have a federation server and it fails, you use a login on one system to access another service. When this federation server does not respond to queries for some reason, backup access must be established. Most frequently, from our practice, there are systems like MFA systems, multi-factor authentication. Our systems are simply overloaded, especially when users in a large company make numerous attempts to sign in. Something may go wrong. These are popular cases where the infrastructure might go down, might experience an outage, and still you require a way to access these resources and start controlling them, managing them in the event of an emergency. All the break glass technologies can be broken down into various types depending on architecture. We can break down the most popular approaches. For instance, there is a versatile account. If you lose access, I know, okay, I'm going to pull up this user account granting full privileged access. You can actually sign in via this user with privileged rights account on a separate server. Or you might have some tokens, or rather secrets, which don't have a long lifetime. They're designed for short period access. You sign into a system, quickly resolve a problem, and then sign out. These tokens, they have a short lifetime, and there is a dedicated pipeline for this. How to get this in the event of an emergency scenario. Third, roles. This is another subtype of break glass access. You know, a sequence that needs to be performed in the target systems to grant specific privileges that grant you privileged access rights, or a user account becomes an admin. So you can sign in and tweak it. When I refer to a backdoor, it is normally in the good sense of the word. So this is when you can disable MFA system, you unlock it to quickly get privileged rights and access your target infrastructure quickly. And there are a variety of approval rules that apply in various scenarios. If you look at this whole infra architecture, there are several patterns that work for all systems. A token, a secret access with this token, or a scenario that you activate in the event of a bad incident, and that grants you privileged rights. If we take a look at all of these technologies and we consider key types of such technologies, if we specify some key criteria, to which extent is a given technology secure, how easy it is to compromise, how easy it is to deploy, a criteria for ease of use in the event of an incident. For instance, it's easier to create an account rather than following a certain pipeline to get a secret or token. Auditing. Something is easier to audit rather than auditing multiple attempts, multiple tokens, multiple secrets. Who goes there? And potential for unauthorized access to the break glass system per se. Yes, a user account is something which is known to an insider. A secret could be leaked one day, unlike other approaches. If we establish such criteria, then we determine some formal attributes like low, medium and high. Low is super cool, medium is fine, high is high. Let's consider a simple criterion like security level. You have some scenarios where an account can be compromised. If it's used for break glass purposes, probably it's not that safe. So we'll classify this as a high risk scenario. If you have some tokens that have a lifetime of several hours or days, the risk is lower. If we build this criteria chart and if we provide for formal classification of solutions, we'll find out that some solutions are a compromise between usability, the ease of use, and the level of security that they ensure. Let's take a look at this table, and you can see right away which break glass systems are a compromise, something which is a middle ground. Let's suppose. Any ideas? Temporary tokens. From this table, tokens seem to be a pretty easy and safe way to establish a reliable break glass system. But this is fraught with the risk. It is the token per se, the foundation of this technology. If we Google what was established in break glass incidents, normally the vulnerabilities are weak access controls, the tokens that must grant you the highest privilege. Sometimes they leaked or used by an insider. Inadequate monitoring. This is obvious in various federation systems. You get access via one system, and this access is used for other systems, and they do not monitor how tokens are used. And the final, most tragic, most critical case is a single point of failure. This is a system that grants access to everyone in the event of an incident. This SPOF might be under attack, it might be unavailable. It is the source of all secret knowledge that manages the infrastructure. You can come up with a variety of other scenarios, especially when there are a variety of infrastructures, various clouds. You might have infrastructures with multiple clouds. The policies of one cloud may not apply to the policies of another cloud. That leads to some deficiencies which may be exploited, even when you have a break glass system in place. If we are to summarize the deficiencies of such systems, we can actually establish two criteria. The presence of a system. This yellow sign means if everything goes through this one, it is a single point of failure which would be the target of attackers. or it would be under a DDoS attack. And second is the secret. The user who knows the password when they want to use the break glass access. And this is a basic limitation of all the available break glass systems. Hence the hypothesis. Can you build any access that would not be associated with any secrets vested with a user? It should have a short lifetime. It should die immediately after an incident is resolved. This brings us to the architecture of a system that respects two requirements. First, it must be accountless. No accounts that may be leaked. There must be no single point of PAM. It must be backed up. It must be spread across the infrastructure. And there must be no privileged user account, because there are a variety of incidents. And CVEs are identified on a frequent basis. And Evgeny is going to touch upon the system that was built on top of such suggestions. Thank you, Denis, for your contribution. Distinguished audience, before we proceed, I would like to highlight two important points. First, something we do not do in our presentation. We do not solve the problem of management of credentials of users, because this is a major separate topic. Which problem did we solve? Our point of reference. Nothing is available, but the connectivity to hosts. Our job is to ensure a secure access to this host and start rebuilding our infrastructure. Where did this path start? Let me give you some background data. Some time ago, we designed a platform for privileged access management, hereinafter referred to as the platform. We managed all the three levels, but at the start of our survey, let's call it like that, we were most interested in the core layer. Why the core layer specifically? Because the components of this layer impact the platform as a whole. Authentication, authorization, and monitoring, and others. These are pretty well documented as separate components, and we paid attention to the following fact. Break glass is a component. It's very poorly documented, and normally it is implemented based on pretty simple mechanisms that just work. After considering these mechanisms in greater detail, we discovered the following. There is the SSH protocol, there is a pre-created account, a password or key which is stored somewhere in a secret place. At our age, we pull it up and get access to our infrastructure. Since we decided we want to move away from password-based access, we decided to study whether key-based access is secure for authentication purposes. It turns out that in the field of information security, there are some aggregated surveys and studies covering the pros, the cons, the solutions, mitigation measures. And the first study we paid attention to was conducted by the creator of the SSH protocol. And they state that 90% of keys that were ever delivered to a remote host, they're not used. And 10% of these are keys that might be used with higher privileges. If it's a Linux-based system, it's going to be a root account. Another survey suggests that most companies never configure the key-based access on their hosts. What does it mean? The file that contains the open part of the key is stored in the home directory of a user. Therefore, the user can enter as many other keys as they want, bypassing the platform. Thus, they remain undetected. And we come to the following conclusion. One of the main problems of key-based authentication is the problem of managing them. We identified the following restrictions an admin will encounter when they decide to build keyless, passwordless access. First is limited metadata. According to the SSH specification, there are some fields we can use for various purposes. If we want to transfer something which is custom-based, it's not a trivial task. It takes a specific mechanism to be developed. However, the main problem associated with key metadata is that it's not protected in any way. If a user can access a file that stores the open part of the key, they will be able to manipulate that in any way they want. Second, managing unused keys. Since a key per se is not associated with the user in any way, it's impossible to tell who that user is and whether this user will be legitimate in the system. Connection of multiple data sources for looking for key segments on a remote host. According to the initial SSH specification, the system administrator may configure multiple data sources to look for an open key, thus disrupting the operation of the platform. And users manipulating keys freely, the way they see fit. This is a follow-up on the previous point on metadata and the number of keys they can use to connect. They can add a user-defined number of keys, and there will be no way for admins to know that. Key rotation. This is not all something that applies to keys only. This applies to certificates as well. The problem of rotating or revoking trusted public keys is something which is not solved in the information technology segment as a whole. Monitoring all that is not a pleasant process. If we lose something out of sight, there is a chance that we will fail to detect an intruder, an attacker. Then, an administrative aspect. There is a simple example. There is the free APA, and on the hood there's LDAP. If a user has more than one key, say 3 keys for different purposes, if we have 100 users in our system, 100 multiplied by 3 is 300, which is not good for LDAP. If we want to scale the LDAP to make sure the system is fault-tolerant, we will run into problems with performance. Once we've studied all that, we get a feeling that keys must be a Trojan horse. Sooner or later, if we do not monitor keys correctly, we will run into problems one day. Sooner or later it will happen. Then we develop requirements to a system we would like to see. And meeting these requirements would facilitate the management of the infrastructure. First and foremost, we don't want any keys, we don't want any passwords. We only want to get access. It must be keyless and passwordless. Secondly, it must be based on well-known protocols. So, PNC-RDP is not our way. The break glass component must be separate from our platform. This is something Denise suggested. We solve the problem of a single point of failure, SPOF. If the break glass component runs on the platform and the platform becomes unavailable, we cannot secure timely access to the infrastructure to resolve or mitigate a critical incident. Server-side authorization. This is a follow-up on the previous point. Nothing is available, but we need to somehow authorize a user and allow them to do something on our remote host. No pre-created accounts. This requires no comments. It must be accountless. Unused user accounts is a bait for attackers. Simple integration to existing infrastructure. We wouldn't want to reinvent the wheel, and a lot of companies have established systems running on established protocols. We would like this to dovetail organically with the existing infrastructure. Short-lived access. If we granted access to resolve an incident to someone one day, we don't want them to reuse this access in 1 month from now and do something they were not supposed to. And one of the final points that we care about is this. Critical components rotation. For instance, if we suspect that our break glass mechanism has been compromised, we must have a protocol, or rather a function, that would allow us to replace our break glass mechanism and mitigate the fact that it has been compromised. There is a solution out there. This is a certificate, open SSH certificate, not to be mixed with other SSH ones. It was a big surprise to us. Why so? At the moment, still, there is no mechanism that would solve two problems at the same time. Why? First, server-side authorization independent on shared accounts, accountless. It's clear about authorization because OpenSSH is not supposed to be doing that. OpenSSH only ensures authentication. In order to solve these two problems, we need to understand how the SSH protocol works. The SSH protocol works on top of the TCP/IP, and there is a protocol that is responsible for user authentication. This is what we need. The specification says that if a user does not exist, then OpenSSH or the implementation SSHD, under no circumstances should the protocol authenticate a user. It should actually confuse the attacker. You authenticate with a key is not found because there is no user, and they suggest that you enter a password. And the password is not going to be correct ever, because the user simply does not exist. Here is a diagram. When authentication query is submitted, the SSHD talks to NSS. It talks to pre-configured databases, could be LDAP and NSS, and then we decide what needs to be done with this user. The next component involved in authentication is flaggable authentication modules. not to be confused with the platform of the same name. This interface in a Linux-based system allows us to expand the authentication. For instance, by adding MFA, multi-factor authentication. When depicted on a diagram, it looks like this. We have an authentication query. We're looking for a user in the database, in a local database or in a remote database, and SSHD checks whether the PAM interface is on. If so, then it proceeds with extended authentication through PAM modules. The task was pretty clear to us. We can create a fork to open SSH, write a protocol, or write a small PAM module would fit organically with our system. The choice was absolutely clear, but if an attack looks pretty successful, there must be an ambush. If a user does not exist, we should not authenticate them. It means that the PAM interface is not going to be available. If the PAM interface is not available, it means that the user does not exist. So this completes the circle. Now on pitfalls. In order to find out what is going on, we started investigating this problem, and we ran into a few pitfalls worthy of your attention, and which yielded interesting outcomes. In order to resolve these problems with PAM interfaces, we decided to elaborate on SSH API. NSS then retrieves a user and retrieves a pre-filled structure. GIT, home directory. If it's not there, then it's empty. And we thought, why don't we write a module that will take over the search query? If a user does not exist, we will create a user and we will return a message that says that a user does exist. We did exactly as described. There is a certain application that calls as NSS API. Our module takes over the query. We create a user in the runtime, and everything works. But that wasn't it. We ran into an interesting side effect, as they call it. In the NSS API, it's impossible to limit the list of applications that may call it. Therefore, any query is considered as legitimate, which is quite right in terms of system administration. And there are multiple utilities that call NSS. One of these is ID. It returns a user's UIG. In terms of system administration, when a user logged in legally, they check whether such a user exists in the system, and it's being created dynamically, and if not, it returns UIG ID. In terms of administration, this is incorrect. We thought, okay, and we moved on.
Дело в том, что NSS API.
The matter is that the NSS API, when implementing a module via NSS API, allows us to use a system variable, an application that calls the NSS, and it caught our interest. What did we do? When NSS is called, our module takes over the query. It takes a look at the PID of the process that called the API, and via the proc file system, we retrieve the process name that calls the API. Overall, that works, but the problem is still not resolved.
Мы можем ограничить динамическое создание.
We can restrict the dynamic user creation in this system. If a query does not originate from SSH, but if we connect via the SSH protocol to remote host, there is no way for us to limit that, because all queries, in terms of the connection, are considered as valid. So we decided to mitigate this problem somehow.
First, немножечко запутать атакующего, если он вдруг
In order to confuse the attacker, in case they decide to exploit this opportunity to connect to our remote host on a constant basis, and our NSS module will be creating users on a regular basis. We suggested adding a prefix or postfix for user to be created. Two conditions must be respected. First, NSS API must be called by SSH, and the user we connect to must have a certain sequence of characters for a user to be created. Awesome. Almost there. Almost there. We have successful authentication. The user is logged in. But what can this user do? It cannot do anything. Yes, it can create a file in the home directory, or probably they can take a look at the process list. And there is hardly any point in that, because we need to perform some administrative task. The next component that comes into play is PAM modules. As we said earlier, PAM modules expand our authentication protocol, and by using PAM, we can impact the rights a user is granted within the system. Since we connect with a certificate, and certificate does have some metadata, and the metadata is signed by a secret key, which is impossible to fake, via an SSH auth info variable, it gets certificate. It pulls two fields. We don't have to pull principals, but it might be useful for any additional checks. Username from the principal's metadata must match that of the user you're connecting through. Otherwise, the connection will be terminated, because it would be incorrect from the standpoint of SSH. The username must be the same. The key ID is one of the critical fields. Key ID is most frequently used for auditing purposes. When we log our connections, the key ID might contain a policy, a password with which a certificate was issued. It may indirectly indicate the rights, privileges a user have, whether these are extended administrative rights and privileges. In order to simplify the audit to a certain extent, we introduced a naming convention that contains three fields. First, resource type. This is for informative purposes only. This is purely informative. That helps us differentiate resources. This is chiefly for monitoring purposes. Environment, we're connecting to, whether it is dev, test, or production, or any other environments, if any. And the pseudo group. This is a field based on which user rights will be granted at the host they're connecting to. And this is the high-level design diagram. As suggested earlier, we do not solve the problem of certificate management and authentication management. We say that someone issued us a certificate. We connect using this certificate. The user must respect specific criterion. The module analyzes the certificate, creates a pseudoverse file, a user directory. We have authenticated with specific privileges and rights, and we can carry on operations. What are the known limitations? Real quick. Only one type of keys is supported. We wanted to make this real quick in order not to expand the code base. Every new user will have unique UID, GID. GID is not defined in etc groups. I don't know why it's simply not implemented in the context of break glass. All break glass users are ephemeral. Once you disconnect, all the logs of users, their details and home directory will be deleted. If under break glass user you run a long-term process, the PAM module that performs cleanup. It will not refer to the current implementation, which processes are running. It will simply delete this and the process will keep running. There is finally an unpleasant thing we're still not sure how to deal with, but still it's there, it exists. If you connect via SSH, and for some reason SSH fails to authenticate you, the user details will remain, will be stored, but the home directory in this pseudoverse file will not be created. And finally, some closing thoughts. What is the mission of our contribution? It's important to mention the restrictions. Can you hear me now? Yes, you can. Awesome. Restrictions do not matter if several people are dealing with that, and we convened together today to deal with these restrictions, because there are no blockers. Our job is to contribute to this idea, and probably this idea will land on someone's infrastructure. Therefore, we published a report, a white paper. You can refer to this as an architecture document. Please feel free to check this out. You can submit your contributions. You can provide suggestions, ideas, or criticism. And we published a prototype. This is just a crutch that we wrote. Well, not quite a crutch, it's actually a full-fledged project. If you scan the red QR code, it contains full details that would be impossible to cover within the time frame allocated for the conference. And the code is pretty well documented. If you feel interested, please scan the code and check this out. And there is an example you can run in a container and try to operate as the admin of a break glass container. It's fully automated. The only thing is you have to do is to create a sub-memorandum. Thank you very much. We're looking forward to your questions and your feedback. Thank you. Thank you very much. Any questions? Please hand over the mic to the person over there. Thank you. This book is to be awarded for best question. Thank you very much for your contribution. It was very inspiring. I have one clarification question and a question. A clarification. In one sentence, how could you describe the essence of what you did? In one sentence. I tried to grasp the whole scope, the gist of it, but I somewhat failed. But I do realize the subject matter. In one or two sentences, just one, Evgeny. So, we provide one sentence each. If you like our sentence, we get the book. Solving the problem of break glass systems where there is no single point of failure, with using zero trust, keyless, passwordless, and yes, keyless. Then questions. If you say there is no single point of failure, hence we might elaborate. One point is easier to defend rather than multiple points. If the components of information and security and cybersecurity are broken down into multiple components, it means that you must allow for a situation where all of these are broken into, or at the root level. You say we have two, one is for that purpose, the other one is for the other purpose. It turns out that there are two points of failure. You break just one and the system goes down. Or probably I didn't get this quite right. Answer. The break glass system lives separately from the privileged access management system. Breaking the break glass system. Our job was not to solve the problem of user management under break glass, but breaking break glass. If we just suppose what I thought about, we can split the key in three private key. A private key could be split into three parts. There could be assigned to 3 engineers who will use it in the event of an emergency. So how do you break into that? You need to get hold of all these 3 people, which store 1/3 of the private key. Certificates do not equal keys. I mean, the private key used to sign the user account certificate. You mean the certification center issued a certificate, then it is split in 3? Yes. Let me drill down on the details. So it all comes down to the single private key issued by a certification center. That's a good question. Actually, I have a pre-canned You can transfer multiple SCP certificates because under the protocol specification, the file storing certificates might be a list of certificates. You may do like this. You have the privileged access management platform. If it's available, you can issue break glass access via the platform. If it goes down, the guys who take out USB flash drives out of their pockets, they will use these and issue a certificate, but still. So this is broken down. I got it. And this is the cherry on top. We have the regular SSH access. We issue a certificate to a user, and they are in a PAM system. This is the as before. You want the system to have the following features. You added 2 tasks, 2 objectives. This is your idea. No. The idea is the following. There should be no pre-created conditions. If a user does not exist, they will never be authenticated via SSH. So you must create a user in runtime and decide on the host you're connecting to which rights they require. The NSS API as a module decides on the creation of a dynamic user in the runtime, while the PAM module decides on the authentication. And how do they get to know the password? There is no password. They are issued a certificate. So still issue a certificate. Of course we do, and there is no workaround. I just failed to get this point. I'm sorry, now I got it, thank you. And to create this user and that system, you refer to the existing certificate, yes. So there is still some pre-issued certificate. There is no user. There is a certificate, the CSA certificate, that checks that the certificate you use to access a host is issued by a certified center. This is basically just the way SSH works. So it is pretty easy to rotate using hash. We can take this to the corridors of the meeting. If you have any other questions that do not require a long discussion, please ask these. If not, please remember to hear it again for our speakers. You say that if a user runs a long-lived product, it remains in the system after the session is terminated. Under which user does it run? Under the user you signed in with. So the user does not exist, but the process runs under this. In a Linux system, if you delete a user, there is a user deletion scenario. Normally there is a check, but still it's not implemented. We didn't have the time to implement this check. Thank you very much, guys. The book for best question goes to... Do we have the time for a third question? No, we have the time. You're welcome. Hello, thank you very much for your awesome contribution. I have two questions. Did you study the concept of establishing a connection initiated by the system, so that a connection is initiated from the inside? This is question number one. This is a way to find a workaround for a pre-issued token, and it's being compromised. So it's created internally when needed. And did you find a workaround for deleting a user under which a process runs? This may cause data loss. This may cause exceptions or errors. Any ways to solve this? Thank you. Could you please, Denise, take the question on tokens? I would answer the question regarding the problem of users being deleted with processes still running. Since break glass is an entire ecosystem that entails an entire layer of the system, we leave some aspects out of scope. For the sake of time, let us say that we do not consider this, but it's a good suggestion to consider various corner cases when you delete a user. It should not be invasive. You must be operating with limited context, with limited files. We can continue the discussion on tokens if we have enough time. Apart from in-depth questions, we have various ideas suggested. So the guys posted QR codes for good reason. Hopefully, in 1 year, we will see a next stage of development of this approach. Two candidates for the book. The first person said that the questions will not be boring. It was a challenge, delivering a presentation in 2 minutes, not in 40. And second was the contribution. This gives us some food for thought. What do you think? I trust you. Thank you.